For me, deep tech is a beacon of hope, and I hope I can explain here a little bit more about what it is, what the context of it is in the innovation cycle, what the challenges are that deep tech companies face, and what we're doing as a private conglomerate to help catalyze the uptake of these solutions, which is not just good for society, but also very good for business. So I think I would be remiss by not saying first that hunter-gatherers, our ancestors, would have considered us gods. We fly in helicopters, we produce free energy from wind farms, we bring Amazon packages from one continent to the other overnight. We talked a little bit about what we'll be covering, but there's a fourth wave of innovation happening called deep tech that's affecting all of these and taking us even further into this God stratosphere. They're facing challenges like any other companies, but corporations like the one that I work for at Libra Group can help catalyze the technologies and help bring these solutions to market. So we're finally getting our flying car. Peter Thiel, a famous investor in this space, famously said, we wanted flying cars and we got 140 characters. For those that grew up with the Jetsons, the cartoon when you were kids, that portrayed the life in 2020 with flying cars and robotics, Twitter was, yes, a disappointment. But we are finally getting there. Today, deep tech is our fourth wave of innovation. The first wave were encapsulated the first and second industrial revolutions. The second wave was found in corporate labs like IBM and Xerox PARC. The third wave was known as the Silicon Valley syndrome, small startups, VC fueled and VC backed. And building on the first, second, and third wave, we're now entering this fourth wave, which is gaining a tremendous amount of momentum and feels like the 90s and the internet generation. The first wave, we talked a little bit about this, but this was really the wave that really had a lot of breakthrough scientific discoveries. We figured out how to process crude oil, how to manufacture steel better, telecom, connectivity. The second wave was post-World War II and was built in the corporate research labs, where places like IBM created the mainframe computer and Xerox PARC created Ethernet networking. The third wave is the tools that we use today, Microsoft, Google, Meta, all of these companies that came from the startup world and were fueled by VCs. And now at our core, it's deep tech, our new phase of innovation. So what sets this apart? So deep tech has a big impact on large markets. This isn't a consumer-facing app. This is about impacting the industries that underpin the global economy: transportation, energy, real estate, decarbonization writ large. Most of it is very problem-oriented. It's about scientific solutions to big problems. And as such, it's really focused on the technology itself. 83% of deep tech technologies are physical, so they're really tangible assets. We're going from software to hardware, with its own issues and problems. And it's collaborative. Unlike the software revolution that disrupted the existing companies, deep tech companies that have innovative hardware solutions have to work with incumbent companies, like many in the private sector today, to integrate the solutions and move forward. It's everywhere, and I will go through these very quickly. These are all things that we see in the news every day, including AI, which my colleague just spoke about. Whether it's quantum, whether it's new materials, whether it's nanotechnology or blockchain, whether it's robotics, all of this encompasses deep tech. It's scientific breakthrough that suddenly marries the science with the data and the computing power that we have today. Yes. Industries are being reinvented, like many of ours: maritime, aviation, energy, real estate, and also new ones are being created. Aerospace are accelerated, carbon capture. So I spoke a lot about our big generational challenges and how deep tech is impacting them, and I want to put some weight behind that. There's 4 areas of impact that I thought would be great to highlight here. The first is climate change. We produced 40 billion tons of CO2 last year, which is a huge increase, or in 2022, which is a huge increase from the past. We don't believe that we can get to the place we need to get to stabilize our planet's climate without deep tech technologies, without carbon capture, without nuclear fusion, without solid state batteries. Deep tech is going to be a critical solution to solving this problem. The next is demographics, much quieter, but people are living longer and need to have long, healthy, productive lives so that they are a benefit to society rather than a burden. Deep tech solutions are working on the aging workforce, they're working on drug discovery, drug biomanufacturing, they're working on even things like augmented and virtual reality and factory automation. Technology, we're actually, believe it or not, being pushed to the physical limits of density and speed when it comes to the amount of data we're producing and the technology needs of our society. In this case, deep tech is helping solve this problem with quantum technologies and different types of data storage and semiconductor technologies. And finally, security. Unfortunately, the world is not getting safer, as we've seen with our current state of our global wars, but also when it comes to cybersecurity. So we're not just facing cybersecurity breaches in our consumer lives, but we're also facing a lot of robotic and automation weaponry in our physical also conflicts as well. I think it's important to note that this isn't just a seed of an idea, but this is a growing momentum of an industry. There is a lot of venture capital money going to this, and now deep tech companies with recognizable names are coming out and are hitting mainstream, whether it's Commonwealth Fusion Systems or OpenAI. And if you're visual like me, I really appreciated this graph, which showed that the amount of money going into deep tech companies has risen almost fourfold over the last decade, whereas the amount of VC capital going into it has risen twofold. But now there are challenges to this. There's a huge investment risk. We're looking at technologies that sometimes are just proven in the lab and not in the real world. We're looking at very long technology cycles. We're looking at difficulty to commercialize. If you zone in on the scientific risk specifically, people are trying to create scientific breakthroughs in areas that didn't exist before. Nuclear fusion has been a challenge for our generations, and we're very close to solving it. You also have commercialization risk. With 83% of these technologies being hardware, you need to figure out how to engineer them, how to manufacture them, how to distribute them at scale. Unlike an Instagram or a web app, it's not that you're just downloading code and signing up for something, but you're actually delivering it to the end user. And as a result, it takes twice as long for a deep tech company to get to commercialization and success than it does the traditional technology companies that we're used to. And we're going to shift our mindset as investors and as users to understand that it does take longer, but there is a reward at the end. So with these challenges comes an opportunity, and that's what we saw at Libra Group. We recognized quickly that deep tech companies could benefit from us by looking at what is the problem market fit? Can this really be commercially viable? Is it not just an interesting technology, but is it something that a business wants because it's cheaper and easier and faster? We also realized that deep tech companies really needed the industry expertise. A lot of times they were working on a technology that could be applied to several industries and really needed a deeper expertise there. Yeah. And finally, we could act as a go-to-market accelerator. We could help put purchase orders in and help prove to the market that there was a viable product in this technology.
Yes.
And of course, for us, partnering with deep tech companies was important too. We want to avoid obsolescence. We want to grow and evolve ourselves. And finally, we want to achieve a lot of sustainable goals that we've set out for ourselves, and I think many corporations feel similarly. So this is not all just theory. In fact, the theory emerged from the last 2 years of trial and error at Libra Group with our companies. To take a step back, Libra Group owns and operates 20 companies. Those companies hold a global portfolio of assets across 60 countries, whether that's container ships and bulk carriers, wind farms and solar fields across 5 countries, and aviation, which didn't show up on my slide. How are we weaving the future into the present? The first thing we did was address our primary industry, which is maritime, which have a 50-year track record in. We created Lomar Labs, which is a maritime corporate venture lab, which I personally am very proud of and started about a year and a half ago with some phenomenal colleagues. We believe that our vessels, which travel all over the world, can be cleaner, can be more automated, can be safer. We have a vision for all the innovation that could happen in maritime, and we're working with entrepreneurs to help them get there. Shipping is invisible, but it's critical. It's a $14 trillion industry. It transports 90% of the goods around the world. And it produces 1 billion tons of carbon a year, which is about 3% of gas emissions. So what did we do? We partnered with several startups. I'll go through a few here. The first is a company called Seabound. This is 2 women out of Oxford, PhDs, who had figured out that you can put lime on top of an exhaust and absorb the carbon coming out of a ship and actually capture 85% of the carbon coming off the ship, which is a huge discovery. They had done this twice in the lab and they had raised some venture funding, but no one had ever let them tinker on a vessel. After all, a vessel is $100 million plus asset, and very few ship owners are going to say, come and use my vessel as a floating lab. But that's exactly what we wanted to do. So we allowed them to come on our vessel during dry dock when it was in Istanbul. They put their pilot product on there, and this is a picture of it. We sailed around the Middle East, and they tested and measured the carbon capture. We're able to accurately predict that it can absorb 80 to 90% of the carbon coming off the ship. And because it's worked, we've now put in purchase orders to build this into 4 of our vessels. The second company is a company called Blue Dot Change, which is really ambitious and kind of crazy. But it's a bioengineering company that basically uses our vessels to inject a chemical into the air that absorbs the methane. This is important because methane is 20 times more harmful than carbon dioxide. They've tried it in the lab at Stanford, it works. They've never tried it on a vessel, and they don't know exactly how to get that material into the air. So we're working with them on developing the pilot, on testing it on a vessel in the Atlantic, and making regulatory introductions to make sure that we're doing this the proper way. And finally, one of my favorites, just because it's such an easy and effective tool, is an automatic robotic scrubber. So think of a Roomba, but for the outside of a vessel. So while your vessel transports your packages from LA to China and China to LA, it collects biofouling, and that biofouling causes friction, which makes you use more fuel. By using these automated robotic scrubbers, we're actually cleaning the vessel, reducing the biofouling, and actually saving 5% of fuel costs. It's not a huge amount, but every bit counts, and it's a relatively inexpensive solution for what you get out of it. These are just some examples of how we're using our vessels as floating labs, embracing the deep technology companies, helping them pilot and helping them go through those challenges that they usually face. Aviation is the second largest industry for us and second oldest industry in our group. We have a long history of buying and selling fixed-wing planes, as well as helicopters. And aviation's captured the world imagination, and it's a huge market as well, $1.2 trillion. And it's done that despite the fact that 80% of the world has never been on an airplane. It also produces almost a billion CO2 metric tons. Our aviation leasing company, LCI, which today owns the largest privately owned helicopter fleet in the world, decided to take a look at electric aircraft. We had 25 plus conversations, and the team established 2 partnerships. One with a company called Beta Technologies, which you'll see here on the screen, is vertical takeoff and liftoff, electric flight, very quiet and totally clean. And the second one is Elroy Air, which is a hybrid electric aircraft, mostly used for packages, or primarily used for packages, and that also vertical takeoff and landing. We put in a total of 140, a purchase order for 140 aircraft. In total, pre-FAA approval, pre-manufacturing, so that we can get ahead of this as soon as it hits the market in a few years. And finally, when looking at deep tech and all the new industries that are being created, we said, okay, we lease container ships, we lease helicopters, we lease wind farms. what is the next frontier for us? What can we do next? Where are there other physical, capital-intensive assets? And we looked at space. And after a 6-month kind of run out of hypothesis, we realized that the space industry, which today is about $500 billion in market size, is predicted to be $1.8 trillion in market size in about a decade. So we created Space Leasing International, which is a new subsidiary similar to our maritime and aviation subsidiary that's dedicated to leasing space assets in this rapidly growing industry. We launched about 9 months ago, and our first transaction is with RBC Signals, a ground station company that is akin to an American tower for the telecom industry. And this is our first step into the space assets, and we hope to go into orbit next. So things that we learned along the way through this trial and error of the last 2 years of making sure that we don't become obsolete, that we grow and transform, that we embrace technology and embrace all the benefits of it, is we need to make the business case to the corporate team. No CEO of ours is going to take a technology because it's a cool technology. It has to be better, faster, cheaper. It has to have some competitive advantage. We have to make sure to solve a pain point for the deep tech startup. They need to choose us as well as partners. So we need to be able to help them pilot, help them prove out their technical milestones, help them by putting a purchase order in and proving out their commercial milestones. And finally, we've realized that we can't do this alone. We have created a network of collaborators, whether that's the EU government, the UK government, the US government, both when it comes to grants and regulations. We've worked with academia, like Oxford and MIT, and we're also working with many venture funds that can help co-invest and bring all of these things to market. So 2,500 years ago, a Greek philosopher said the only constant in life is change. And I think that statement was true then, and it's absolutely true now. I think deep tech will have a transformative impact on our world and the private sector and companies like ours and potentially yours. I think there's a future where the private sector embraces deep tech companies rather than shies away from it. We can't run from change. We should run to it. And finally, I think we can do a lot of good, not just for society, but also for our businesses in this way. Thank you very much. See you on the panel.